Hi, welcome back. We have gone through the first 3 pages of the transformation test review, so now let's begin with page 4. Number 11, how many lines of reflexive symmetry does each figure have below? So remember, reflexive means if you fold it in half. Okay, so if you forget which one we're talking about, reflexive, you might want to make yourself a little note that reflexive transformation or reflexive symmetry is looking at folding in half, right? Okay, so where can I divide each figure in half so that I can have the same image on both sides? Well, my first one, my heart here, if I draw a vertical line through my heart, I can see both the left side and the right side will be the same. That's the only place I'm going to be able to fold this figure in half. So this one's going to just have the one line of reflexive symmetry. Okay, on my trapezoid, same thing. I'm only going to have one, because if I try to fold this in half, my top is not going to line up with my bottom since it kind of flares out on each end. And I can't also do the same thing with the diagonal because this piece is going to come way out and this one's not going to fold over far enough to reach it. So this one also only has the one line of reflexive symmetry. Okay, when I come to my star, I can divide this one in half right here. Okay, I can also do that with each of my points. I can draw one here. I can draw one going through this point. And I can divide it in half here. And I can divide it in half here. So how many lines was that? It's kind of tempting to just count how many come out, but remember each one has 2 ends, right? So that's 1 line of symmetry. That's 2, 3, 4, and 5 lines of symmetry. There's 5 ways to fold that star in half and get the exact same image on both sides. Okay, number 12 wants rotational symmetry. So that's rotating all the way back around and getting to land exactly like you look. Okay, my heart is going to have to go all the way 360 degrees before it looks like a heart again, right? Because everywhere else it's going to be a turn around heart until you go all the way back. So this one you have to go 1 full rotation before you'll end up back where you started. Okay, same thing with this one. It's going to have to go all the way around before it's going to land back where we started. So this one is also only going to have 1. I should be boxing my answers. I also didn't box this one. Stay consistent. Come on, Bishop. Okay, then I have my star. My star can rotate here and it's going to look the same. Then I can rotate it here and it's going to look the same. I can rotate it here and here and here. So I have 1, 2, 3, 4, 5 rotational symmetries for this figure. Now, it happened to work out that these were the same, but it's not always necessarily going to be the case that a figure will have the same number of reflexive symmetry as it does rotational symmetry. It just happens to be that way with the 3 that we have on this review. Okay? All right, number 13, how are rotations, translations, and reflections different from dilations? And it says to use good geometric vocabulary. So that kind of clues me in that I want to use some of the new vocabulary that we've gotten with this unit. So we talked about pre-images, we talked about image, we talked about isometry, we talked about rotation, translation, reflection, transformation, okay, and this is how are we different, okay, so all of them have pre-images before you do the transformation. All of them are types of transformations, so that doesn't make dilation different. All of them, let's see, what else can make these different? What are my other? They all have a pre-image, they all have an image, and then isometry. Isometry preserves size and shape. Well, these stay the same size and shape, but my dilation is not going to preserve the size, right? This one enlarges or reduces. So how are these 3 different from my dilation? Well, these have to be isometries. They're going to stay the same size and shape. My dilation is not an isometry. Okay, so rotations, translations, and reflections are all isometries. Dilations are not isometries. Okay, so there is our difference. They're all transformations, but my rotations, my translations, and my reflections are isometries. My dilations are not isometries. Number 14 has two parts to it. What do we call a figure before we transform it, and what do we call it after it has been transformed? So we still are working with our vocabulary here. Before we transform something, we call it a pre-image. And sometimes you'll see it with a hyphen, and sometimes you'll see it all as one word. You can write it either way. They are both correct. What do we call the figure after it's been transformed? That is just an image. Okay? Number 15 is kind of an interesting thing to think about. You kind of have to think in your brain what's going to be happening in the 3D world. So what will be the resulting 3D figure when the semicircle is rotated 360 degrees around the x-axis? So if I take this axis and I take this semicircle that's just on the top and I rotate it, so it's going to be going around this way, like spinning around that axis if I put it in the 3D world. Okay, so what shape does this make in the 3D world when I spin it? When I spin it 180 degrees, it's going to end up underneath, and so it kind of looks like it's going to be a circle. But we're talking about the 3D world, so that means you're going to have little parts in between where it's going to look like this. What shape is going to result as I spin this in the 3D world? What do we call that shape in 3D? We call it a sphere. Okay? Let's look at number 16. These are also a little bit different, kind of getting us to think outside of what apply the concepts that we've talked about. What will be the horizontal and vertical cross sections? So cross section means if you sliced into it, what shape would we get when we sliced into it? So think if I made a horizontal cut across here and then I opened it up and saw what shape I made, what shape would we see when we cut this and we wanted to look at this at a horizontal cut? What shape is this going to make? Okay, kind of looks like a parallelogram, but remember this is in the 3D world, so it's going to make the same shape as my bottom. My horizontal cross section is going to be a rectangle. My vertical cross section is going to be, if I were to slice it straight through the top down to the bottom, what shape would I image? Or what shape or image would I end up with? What is my vertical cross section? So that is, if I were to slice it this way, what shape am I going to end up with on the inside? I can see I'm going to end up with a triangle. Okay, so I think I meant to do one on this picture and one on this picture, but that's okay. I did them both on the same picture. So horizontally, I'm going to get a shape that matches the base. It's just going to be a little bit smaller, right? And then my vertical is going to be a triangle for my vertical cross section. Okay? All right, and that is page 4 of our review. We have one more page left, so come on back to the next video to see the final page of example questions. Thanks for watching.